No, it's not rank.
I don't like being free.
I met Jerica first. She's student number 1. It's all uphill from there. All right.
I had to make sure you got
It was
So you hit rock bottom. Love you. All right. Welcome. We're given.
My knees hurt.
Oh wait, actually, here's what I want you guys to do first. This is what I want you to do. I should have graph paper back there, paper back there. Go get some. Go. And have someone else go get it for you.
Hey, Matt, can you give me a pen?
I'll get it for you guys.
Yes.
Give me one. Go for it for Taylor.
Did I really get it? The whole time. Every time.
No, green. No. You got 3 plus 2 on that. Please.
We're live? Do it in Mexico.
I can't use it. I can't use anything.
You guys like me, you know?
I do know.
Are we running this?
Yes.
You already used a lot of cards. Can I do it? Actually, yeah.
I need a nickname.
I thought it was hot.
Okay, not in our group chat.
Not really.
Well,
Like an actual one that means something.
Dude, we gotta win this.
Do you like these pants? I've never worn them before.
well.
And they look weird. Oh crap.
But first,
Yes,
it's like,
we do.
we got
We do. Yeah.
student A again. You
Yes,
see that?
I promise.
Mr. Mack, do you want to get
I
started?
do.
Now I'm about to throw a 2 at him.
Not just in here.
They're throwing 8s at each other.
They lost it.
Yes.
I didn't even just you.
All right, here it is. So, given this information, we're going to prove that triangle ABC is in fact isosceles. Now, what is an isosceles
Do you have
triangle?
to draw that?
Welcome to class. Who can tell me about an isosceles triangle? Yes.
Aren't these made up of a right triangle? 2 right triangles.
I didn't say that.
I'm guessing.
Let's go.
Yeah, we're just
Finally.
Oh, I thought you were asking a question. Okay, I hear what you're saying. Pardon me, I am sick. So, an isosceles triangle is made up of 2 right triangles. This is sort of true. Not just any type of right triangle, though, because there's lots of different kinds of right triangles.
Like
Yeah.
cute, right?
And a cute right triangle.
A right triangle with a hypotenuse leg.
Wow.
Honestly, let's just give up on hypotenuse leg because it failed me a lot yesterday.
Hypotenuse is the side opposite the 90 degree, and the legs are the other ones.
We get it now.
That's good. That's the whole point. Anybody know anything about isosceles triangles? Yeah.
It has 3 angles that are the same.
Ooh, close. That's an equilateral. That's where all the things are the same.
side.
So,
I just can't see
she
it.
brings up a good point. Equilateral triangles are when we have all the sides the same. That's why they call them equilateral. Who could it be now?
It's for me.
Hello? Yes, I can. Right. Yep, fine. All right. Guess what? Taylor Swanstrom has to leave. You have to go to the office.
Okay.
It's like
Yes.
there is a God.
Thank God.
I'm smelling.
Bye, Taylor. I miss you.
Time out.
Is everyone here, by the way?
No. Oh, I got to see
Are
you.
you raising your hand?
Yes.
How can I help you?
I was going to say, an isosceles
Oh, hold on. We're not done
Oh.
yet. Equilateral.
I need to wear my glasses.
Is this one boy?
Can I have a new seat?
So technically, this is also an isosceles triangle because isosceles triangles have to have 2 sides that are the same, and this one has 2 sides that are the same. That's what you were going to say. Equilaterals have all 3 sides the same, and you'll notice all 3 angles are the same as well. That's an equilateral triangle. All things are equal in equilateral triangle. That's why they call it equilateral. Isosceles, is when you have two sides that are the same, which then implies that two angles are the same. So, fun fact, if these two sides are the same, then their opposite angles are the same. So this side corresponds with this angle, right? It opens up into this side. So this angle is going to be the same as this angle because these two sides are the same. And we're going to prove that today.
Why aren't they called bilateral?
Bilateral, two
I was
lines,
saying, this is what I was going to say.
because they have three lines.
You said equilateral means equal sides, so why didn't you say that?
I have that. That's a great question.
Isosceles, you know how you remember that because you have two eyes. That's how I've always remembered that.
Can you have
Why
a
do you have three?
Some people don't have two eyes.
Two
Not everyone has two
Can you
eyes.
have a two-sided
Very
shape, or
ableist.
is that like not a thing?
Two-sided shape. All right, so we are going to prove basically this theorem that says, look, if two of the angles are the same, then two of the sides will be the same. Basically, if you have two angles that are the same down here, then you have an isosceles triangle. And we're also going to prove the reverse, that if these two sides are the same, then those two angles must be the same.
Oh, never mind.
Looks like you.
Why are you stepping on my shoes
Go ahead.
for?
Hey, Arnold.
And
Hey,
my sister, drawing of a.
how she makes her money is her own business. All right. So, we're given this much information. Now, it turns out I don't need to tell you that this line right here is 90 degrees. What I can instead do is just give you a triangle that has two angles like this that match. And we can prove that that triangle must be isosceles. I drew that extra line in because we're not used to drawing our own lines. But there is a theorem, or I guess a postulate, that says that whenever you want to draw a perpendicular line, you can. There's always a perpendicular. So, if we do this, you'll notice that we have shared sides, right here. And by linear pair theorem, we know that has to be 90 as well. And so now we've got angle, angle, side, which proves the triangles are congruent, right? And after we prove them congruent, we know their parts are going to match up, so the hypotenuses are going to be the same, and so are these segments right here, right? And when we do that, it's going to show that hypotenuse is the same, hypotenuse is the same, so we've got an equilateral triangle, or isosceles triangle. So let's begin on that journey. So first off, we said shared side, right? So CD is congruent to CD by shared side.
That makes no sense.
What doesn't make any sense? CD is congruent to itself. So CD of this triangle is congruent to CD of the other triangle because they are a shared side. So Courtney, do you see the shared side? That's what we were doing last week. Okay. And so now we know that. That's good. Then we said, I know this angle is also 90 because I can do linear pair theorem. So normally what we do is we'd say angle ADC and angle BDC are a linear pair. By definition, they add up to, or they're supplementary, and by supplementary, that means they add up to 180, and if it's 180, we subtract it, we get 90 left over, so this guy's gonna be 90. We're gonna cut through all that crap and just say, by linear pair theorem, measure of angle ADC equals 90 degrees. Remember, linear pair theorem says that if you have two angles on a line, which we do, the two red angles right here are on a line, then they'll be supplementary. And if they're supplementary, you know that means they add up to 180. And if they add up to 180, I can then use subtraction property to subtract this angle. And what's left over is 90, so this guy must be 90, right? But we're cutting through all that crap by just writing this. So now we know that's 90. And now we're going to prove the triangle's congruent. So by angle, angle side, triangle ACD is congruent to the other triangle. Now let's match up our stuff. ACD is going to be congruent to the other triangle. So what matches up with angle A? B, because it's made up of the hypotenuse and the unknown side. Hypotenuse, unknown side, right? Also, they're labeled together, so that's a pretty good sign, right? So B goes with A. C on this triangle is this angle right here. It's made up of the hypotenuse and the known side. hypotenuse and known side. So C goes with itself. And then angle D goes with itself as well, because we have known side, unknown side, known side, unknown side.
This is gonna
Okay? We're going to go back over it. So now we've proved the triangle's congruent. We know that their parts are congruent, right? If the whole thing is congruent to the whole thing, then the parts are congruent to the parts, right? We're going to start matching up stuff. So we already said that these two angles are going to be the same, right? We can also say stuff about the sides, right? If the triangles are congruent, then what is CA congruent to?
CB.
CB, right? They're the same. So, what I'm going to say is that by, and this is a new one, guys, corresponding parts of congruent triangles, Cpct. Another one that I'll probably use more often, because this is specific to triangles, I'll probably use CCP, corresponding congruent parts. Whichever one you want to use. I usually use CCP, corresponding congruent parts. Corresponding means they're associated, right? We talked about corresponding angles in here. Congruent parts mean that they're parts that are congruent that go together. So like A and B are corresponding, right? C and C are corresponding. D and D are corresponding. Are you with me on that idea? I know it's kind of a new one. It means they match up. So notice we said AC is congruent to CB. And if you look here, AC and CB are in the same spot. AC, CB. So they're going to be congruent. Corresponding parts are congruent. So after you prove a triangle is congruent to another one, that means their parts are going to match up. The question is which ones match up, right? And we showed that angle C must match angle C, angle A must match angle B, D matches itself, and these two sides match. So we're going to say that by CCP, we know that AC is congruent to CB. Therefore, triangle A, B, C is isosceles by definition. Swag box. All right, so let's break this down. Okay. We start with a fresh diagram, only doing what we were given. Try to digest what you just wrote while I'm writing this. All right. So here's our fresh diagram. We want to prove that this ABC triangle is isosceles, the big one, right? And we know by definition, right? The definition of isosceles means that it has two sides that are the same, right? So what we want to do is prove that two of these sides are the same. So first off, we said CD and CD are congruent by a shared side. So that for the left side triangle and the right side triangle, they share this side. Everybody cool with that so far?
Yes.
Okay. Then, by linear pair theorem, angle ADC is going to be 90. And the reason for that is, remember, linear pair says if two angles are on a line, which they is, then they're going to be supplementary, which by definition means they add up to 180. Then if we subtract this guy from the total, right, we get 90 left over. So it turns out this is 90 as well. So, by linear pair theorem, ADC is 90. Everybody cool with that? So what I'm doing is I'm just trying to get as much information as possible on my diagram. That way I can go there, prove the triangle's congruent, and then if the triangles are congruent, then corresponding parts will match up. So last I'm going to prove the triangle's congruent by angle, angle, side. Does everybody see angle, angle, side? Okay, that's what we were doing last week. So that means the triangles are congruent. Which triangles? A, C, D, and B, C, D are congruent. Okay? Then by corresponding congruent parts, or corresponding parts of congruent triangles, whichever one you want to use. I pretty much only use this one, corresponding congruent parts. If you've ever been in Sunday school and they ask you a question and you haven't been paying attention, I did this all the time. I almost became a preacher. Still might. And they ask you a question, and you blank out. You didn't even hear the question. You know the right response. Is the answer Jesus? And they go, yes, Timmy, good job, right? And they give you a pat on the head and a piece of candy, right? If you're worried about the answer is almost always CCP. CCP is like the Jesus of answers. Is it CCP? Yes. Great job, Jericho. Right? You know your stuff. So, corresponding congruent parts. We know that AC is congruent to CB. Why? Because if you look, after we matched up our triangle, right, this is why it's important to get your letters correct. Notice that AC and CB are corresponding. They're in the same relative location, aren't they? That's what corresponding means. Remember, corresponding angles are in the same relative location. AC and BC match up. And that makes sense, right? The hypotenuses would both be the same if the triangles are congruent, right? So we write that. And that's our reasoning. So we know that these two sides are congruent. So I'm going to mark them. And now if you look, we have two sides of our big triangle that are the same. Which means by definition it's isosceles. Do you feel better seeing it the second time? Not at all? Did I have you up to here? No? What about here?
Yes.
All right, we have the shared side. This is fine. This is the first time doing it, guys. That's the whole point. So now we're going to go back here. By linear pair, these two guys must add up to 180, right? So this was the one that was given to us. So if that's 90, the other must be 90. That's all I'm saying. Better now, right? By linear pair, they must be 90. Then I can say by angle, angle, side, the triangles are congruent. See the angle, angle, side? Are we good with angle, angle, side for both? Yes?
I feel like if I just get a random one, they'll forget.
Exactly, right. It's going to take some practice, and you're going to start to see what we need to do. Okay? I'm going to talk about that in just a second, okay? I know it's like feeling like you're floating in space, but we're going to learn how to walk, okay? So, is everybody good up to here? What? Okay, so we're good up to here. By angle, angle, side, I know these two triangles are congruent. Angle, angle, side. I didn't have this yet, right? Cool. So that means the triangles are congruent. Are we good up to there? And if the triangles are congruent, that means their parts match up, right?
I'll get
Do you know what I mean by that when I say their parts match up? If I have two triangles that are the same, let me make some triangles that are the same. Oh no. All right, these triangles are congruent, right? They're the exact same thing. If they're congruent, that means their parts are congruent. Which parts? Well, these parts match these parts, right? I think you guys can tell that this does not match this, right? So when we say triangles are congruent, we have to point out which parts go together, right? These guys go together, and these go together, right? So what I'm saying is, I just proved by angle, angle, side that this left side triangle is congruent to this right side triangle, which means their parts must be congruent. Which parts? Well, I'm going to say by CCP, AC and CB are the same. Those two parts go together. This guy matches up with this guy. That's all that means. So if triangles are congruent, then their parts are congruent, is all I'm saying. That's all this means right here, okay? Yes?
So doesn't that mean that the bottom line
Yeah.
also?
Yeah, exactly. All their parts will be matching up. So these ones are going to match as well. Now I didn't need that because all I was trying to do is prove the whole thing isosceles, so I stopped there. But you're right, yeah, they would match up too, wouldn't they? Right? That proves D is the midpoint of AB. Right? There's a lot we can prove here. But all we cared about is proving them isosceles. So once I got two sides matching, I was like, call it day. Right? That fits the definition. Right? When we say by definition, all we're saying is that checks off the definition, right? if I know that we have two sides that are the same, that fits the definition of isosceles, so we can call it that, right? Is that a dog? I don't know. Does it fit the definition of a dog? No, it does not. So we will not call it a dog, right? But this one fits the definition of isosceles. Two sides are the same. So we can call it isosceles. Do I have you up to here? Do I have you up to here now?
Yeah.
For real? Both triangles are the same. And then their parts must be the same. Which parts am I interested in? These two. So I'm going to talk about that. Would be cool with that?
Can you explain that one more time? The CCP
This one?
thing? Yeah.
So CCP, all it stands for is corresponding congruent parts. Corresponding means they relate. Congruent means they're the same. Parts are the parts of the triangle, okay?
Could you have tried to find the other line instead?
Let me answer a question real quick. So AC and CB are going to be corresponding congruent parts. That's what that means. Because the triangles are congruent, that means their parts are congruent. Which parts? These two parts are congruent. These two parts are congruent. These two parts are congruent. These guys, and these guys. Right? So I said I know AC and CB are congruent because corresponding parts are congruent. I already proved the triangle's congruent. That means their parts must be. So I'm allowed to say they're congruent. Words are hard, guys, and it takes a lot of words at first. But I think once you get used to the flow, you'll see it better. Okay? Bear with me. Words are hard. What's your question, Bailey?
Like, instead of finding those two, could you just find the bottom two?
If you found the bottom two, we wouldn't have proved that we have two sides congruent. So we wanted to prove that this triangle, Bailey, the big triangle, was isosceles, so we needed this, right? So if I knew that I had this, that doesn't, you see what I'm saying? Okay, good. I won't use words then. But that's the idea. This is what we wanted to get to, guys, right? That's an isosceles triangle. And we got to that, so we win. Okay? I'm going to leave this up here, but first I'm going to move this out of the way. Your job is to prove the reverse. So we started with knowing that these angles are the same, right? And that this was 90, and we wanted to prove the sides. We're going to do the reverse. I'm going to say if I give you the sides and these 90s, can you prove that these two angles are the same? Okay, so here's what I'm going to do. Just the reverse of what we did. Use this as kind of your guide. We're going to work together. So I'm going to draw another diagram. Can you guys see my drawing? Okay. So A, B, C. Given that ABC is a triangle and that AC is congruent to BC and that measure of angle ADC equals 90, prove that angle A is congruent to angle B. So the last thing you want to write is angle A is congruent to angle B. Okay? It's going to be very similar to how we did it before. I know this is new for you guys. I want to give it your best shot. We'll critique each other's work and try to get used to figuring out how to do this stuff, okay? So I'm going to add this into my diagram. Here's D. And I told you that ADC is 90, so that's this side this time. And I also told you that this and this are the same. So now your job is to prove that these guys are the same, right? Once everybody has that copied down, I'll leave my other work up here so you can see the example. We're just working backwards essentially. It's not going to start at the bottom here. That's not what I mean. It's not like regular working backwards. We just start here and go up. Don't assume that, okay? It means instead of giving you the angles and you got to prove the sides, now I've given you the sides and you got to prove the angles. Small one step in. Instead of giving you the angles like I did last time, you had to match the sides. Now I'm giving you the sides and I want you to match the angles. Okay? Life's not always good to you with, so make sure you're working together. If you have questions of the group, I'll be around to help. Okay? I want you to start with this.
Shelby literally said I
Someone's at the door.
I actually don't know.
linear is so nice. Seriously. I don't know if they're good teachers. I never had to. I don't because I did it out of the way. It's really nice.
I have this class.
Very friendly.
Whoa. That would have made my day much worse.
Oh, I won't. I don't want to get sick again.
Aw, wait, man.
I'm a good dad. Our neighbor is planning to have little fruit.
I need help. I don't know what to do.
Homework. It's not homework.
Thank goodness.
What? You don't
Can
know?
I drink water?
He does have water in his day.
Can I have water?
No. All right, give it your best shot. If you have questions, I'm here. I want you to do the shot on your own. It's okay if you miserably fail. It's your first time doing it. It's not normal. It's mad.
I look more like a guy.
Don't even. Bye.
I saw you.
I literally look like a dude.
I wish I would have, but I did.
Actually, that's
That is especially this feminine side.
guys, should I get a pixie cut?
There's nothing wrong with it.
No, get a perm. I said a pixie cut. I really think I should.
He was commenting on you.
Me three.
What I do?
I always. No, let's all get a perm.
Oh wait, you didn't.
Did you see my video of the started
Cameraman behind the game. He has a good blower.
Did you? That's what I had on my story, like legit 80s perm.
Do you know what it is? Wait, no, it'll be.
I mean, honestly,
Anybody else?
Would you use that process like this?
To prove the triangle's congruent?
knowing what we're doing.
You could.
Equals
It's
angle.
like I have SSA.
There are lots of ways to prove congruent.
I have SSA and then
By
SSA doesn't have to look really
L.
We have a dog like suck. Because you didn't hit. Wait, can you please explain?
That improved it. It's okay.
I thought I actually could get it. Okay,
but
would
you
you
actually
last thing,
don't.
but now I don't know. Yeah, I can do it.
Oh,
The
why?
last thing.
Yeah.
Huh?
It's also
You don't
So,
know.
your first job is to probably prove these things congruent, right? Prove the two triangles, left and right side.
CCP.
No, it's done.
We did that.
Eventually, you did? How did you prove them congruent?
We said CD equals CD by shared side.
Ooh, good start. All right, so, ladies in the front said CD is congruent to CD by shared side. So let's do that. By shared side
Party one, it's 96,
CD
96.3.
is
That's
congruent to
45
CD.
seconds left. Dallas has the
And
ball.
then angle CDB is congruent to angle CDA by LPT.
I like it. All right, so let's do that in red. So then they said angle
Williams is now at the free throw line.
ADC is congruent to angle
Dude, look at their jersey.
BDC by LPT. So by linear pair theorem, those two angles must be congruent, so they're both 90, right?
I just did by LPT angle CDB equals 90.
That's fine.
Okay.
That's another way to do
At
it.
the top,
How do you guys
so-
do that?
Yep, that's fine. There's lots of ways to write it. This implies that CDB is 90,
Imagine
right?
still-
Okay. Now, how can we prove the triangle's congruent? Do we have enough information to get it done?
Yeah.
Somebody
No,
else?
No.
Oh, how do you not?
No, can't use CCP yet. Remember, we have to prove the triangle's congruent first, then we can use CCP.
That's okay. You're saying it.
What?
I was gonna say like either like an AS or something, like one of those things.
Yep, so it looks like we have ASS, right?
Yeah, that's illegal.
Can't use ASS.
HL.
HL, right? Do we have the hypotenuse? Yeah, we do. Do we have a leg? Yeah, we do. So we can use HL.
Yeah, but I
So,
don't know what to do after that.
by HL,
Just eating all the marshmallows.
we know that triangle
Why is it marshmallows? Because it's from August, it's all
ADC is congruent to the other triangle. Well, if I wrote ADC, looks like A is made up of the hypotenuse and the unknown side. B is the hypotenuse and the unknown side. So A and B go together. Shocker, right? D and D go together. And C go together. So by HL, right, we have the hypotenuse and leg that match. Does everybody see the hypotenuse and the leg? I know that was confusing for people the other day. Hypotenuse is the side opposite of the 90. We have both of those matching. And we have one of the legs matching for both, right? So by HL, they're congruent. Now that the triangles are congruent, we say their parts are congruent, right? So by CCP, the rule of corresponding parts of congruent triangles are congruent, right? We know that their parts are congruent. Now, what did we want to prove? A is congruent to B. Are those congruent parts? Well, based on this, are A and B going to be congruent? Yeah, look how they're corresponding, right? They're in the same spot. Therefore, by CCP, angle A is congruent to angle B. And we did it. Swag box. Me too. Yeah, Anna put a lot of swag boxes on her portfolio. That's why I got a triple A+. She was failing this class, but she knew how to pull it together. How do you feel? Do you feel like Bailey, where you're like, once I get one of these on my own, there's no way?
Yes.
Right, exactly. That's normal.
Are you
Okay?
serious?
That's normal. Okay, we're gonna walk you into it. Okay, it's gonna be scary. That's the scary part about proofs. It's not like regular math class, and by regular I mean anybody that's taught you other than me, where it's like follow these steps and you'll get the right answer. Right? That's not how math works. Okay, that's not real math. So it's gonna be scary, but you're gonna be fine. Okay, you have good instincts. What should we do first? Get as much information as possible. Right? Gather clues. Get as many things as possible. And when you have enough to prove the triangle's congruent, do it. Right? Word of advice. And when triangles are congruent, you can prove things congruent.
No way.
Do you see the concept there? I'm going to say it again. The concept that you need to understand. 1, get all the information you can about the triangles, right? Get everything on your diagram you can and back up why you know it, okay? LPT, right? Shared sides, vertical angles, all kinds of that crap, right? 2, prove as many triangles as congruent as you can, right? After that, match up parts and see if you can get the thing you want, right? That's the concept, okay? That's the idea.
That was so rude.
It was. I used to when I had a flip phone, which was for a very long time. I would just take it out when it rang in class and throw it on the ground and smash it. It was great. I did that the first day of class when I taught at Sandwich. It was a good day. Sandwich, Illinois. That's right. My alma mater. Like, who is this guy? It's like, they let anybody teach this class. Not even the real teacher. I just walked in. Oh, the teacher was sick today.
You have a math degree, right?
So, so that's that on that. How do you feel?
Horrible.
Terrible.
All right, we need to talk about some other things first before we get into that packet, which we're going to do over time, over a couple of days. It's going to be fine. It's not homework, okay? First of all, let's talk about some definitions. I'll give you a proofs toolbox that'll have these eventually, okay? But here's some basic stuff. So we know what a midpoint is, right? Nope. I'm just talking about it. Copying stuff down is not necessary in this class. This was okay, so you could work on it, right? But like, we're not doing that. We're doing it. All right, so B is the midpoint of AC. So if B is the midpoint, what does that mean? What does that tell you if B is the midpoint?
Halfway.
It's halfway, meaning that AB is congruent to BC, yeah? Right, that's what a midpoint is. Ready for another definition?
Yeah.
It's super hard.
Is it
The middle.
No friends online.
Is it line?
BD bisects AC. So if BD bisects, bi means two, sec means cut, right? Sec comes up from, right? Harry Potter people? No? What's wrong with you, Half-Blood Prince?
Oh my god, that was so
Oh yeah, what's the Spanish quiz?
Oh, Jeremy, I'm sorry. You said you needed a pen? Sorry, I missed. All right. Why didn't you ask me at the beginning of class? All right. No. All right, so if I say that BD bisects AC, what am I saying?
It cuts into
It cuts it into 2 even pieces, right? Which therefore means B is the midpoint, right?
yes,
You
ma'am.
follow me? All right, cool. Next thing. Yes, ma'am. Bailey, I think you were all right.
got it.
Yeah.
I haven't studied it.
But now you're friends with these losers. thing. BD is the perpendicular bisector of AC. So it's a bisector that's perpendicular. What do you think that means?
It's perpendicular, bisecting it.
It does both, right? So not only does it hit it and divide it into two pieces, it hits it at 90 degrees and divides it into two pieces. You might be, well, what's the difference between these two? Well, this one we don't know what angle it hits at, right? We don't know what angle this is. It looks 90, but we don't know for sure. This one we know for sure. Here's an example of a bisector that doesn't look like it's perpendicular. Do you see how that's a bisector, but not a perpendicular bisector, right? So there's a difference. So when they say perpendicular bisector, they're giving you two pieces of information at once. That's all. How do we feel about these concepts? Midpoint, bless you. Bisector, right, cuts it into two even pieces. Perpendicular bisector cuts it into two even pieces and hits it at 90. This is a bisector, right? Non-perpendicular bisector. Yes? Somewhere, yes. Now, not only can you bisect angles, or I'm sorry, line segments, but you can also bisect angles. So here's an angle.
This is invited.
DB, bisector of angle AB. Does that make sense? DB cuts angle ABC in half. That's true. We're going to learn a theorem that says that any point on this line will be the equidistant from either side here. So if I put a point here, it's going to be the same distance from this line as it is from this line. If I put a point here, it's the same distance from this line and this line. And it works backwards and forwards. So for instance, if I know this,
What's the difference?
if I know this, that those two lines are congruent, that means D is the same distance from A and C, right? These two segments here. That means that DB is also the bisector of ABC. That means this, that it cuts this in half. These go hand in hand. So if I have a point that's equidistant between A and C, right, that line that it makes with the vertex is going to bisect that angle. The same distance from both sides. Let's take a look at that packet. Just again. All right, take a look. What they've given us, we should write down. So I'm going to get some pens, and I'm going to mark it. Angle D and angle E are the same. So I'm going to do that. Ladies, we're not done yet. It says A is the midpoint of DB. So what does that mean? A is the midpoint of DB. What does that mean? Rude.
It's in the middle, halfway.
Yeah, so A is the halfway point between DB. So that means these are the same. Then it says B is the midpoint of AE. What does that mean?
Oh my god.
It's in the middle of A.
Exactly. So this side must be equal to this side. We're going to prove that these two triangles are congruent. Which two triangles? These ones. CDA congruent to CEB. That's what that information means. How do we prove the two pink triangles congruent?
They share. No.
They don't share a side, do they?
Wait, why are we
Share a triangle.
Oh, because it's yep. They share.
We have a theorem that we just learned that we proved earlier today. It's this theorem. So instead of doing this proof every single time to prove that these two sides are the same if these two angles are the same, this is the shortcut, right? We can just say by Isosceles triangle theorem, we know that if the angles are the same, the sides are the same. So check it out. We have two angles that are the same. So what kind of triangle must CDE be? Isosceles, right? So we can say by Isosceles triangle theorem, triangle CDE is isosceles. Rude.
How do you, I don't,
Yeah,
this
I'm
one will
gonna
not
smash
spell.
my phone. It's the school texting me. Don't they know I'm teaching? Probably not. Let's be honest. I'm not actually teaching. So, by isosceles triangle theorem, CDE is isosceles, right? Because we're given that these two angles are the same, which then means this is an isosceles triangle. So that means, therefore, CD is congruent to CE. Because it's isosceles. Now, can we prove CDA and CEB congruent? Do we have enough information?
No.
Can we prove the two pink triangles congruent?
What about CCC?
Nope, remember CCP happens after we prove triangles congruent. If the triangles are congruent, then their parts are congruent, right? You have to first show that they're congruent, and then you can say their parts are congruent. Can we prove the two pink triangles congruent?
Wait, yeah.
How?
Side angle, side.
That's right. By side, angle, side.
When did those sides appear?
They were there, I just knew you didn't see them, so I colored them in more.
Oh,
We got that from the midpoint stuff earlier, right?
sure.
So it told us A is the midpoint of DB, which means it's halfway between D and B. So those are the same, right? And then B is the midpoint of AE, so those are the same. So by SAS, triangle CDA, congruent to triangle CEB. That's it.
Shut up.
So we learned a couple things today. One, CCP, that if the triangles are congruent, then their parts are congruent, right? We learned isosceles triangle theorem. We actually proved it, right?
How do I not?
Isosceles triangle theorem says that if you have this, that implies this, right?
Why do I have two projects?
If you have this, that implies this.
The whole.
This is isosceles triangle theorem.
We gotta win this.
Lastly, we learned about bisectors, right? Means to cut in two. And a perpendicular bisector means it hits at 90 degrees and cuts it in two.
Dude, I'm so good.
That was fun. It's
Oh, it is.
sausage.
See if you can do number 2 on your own for homework.
No.
Everybody know what this symbol means?
Perpendicular.
Perpendicular, which means it hits it at 90 degrees. Do your best.
Is this homework?
Do the best you can. Just the second one. Do the best you can. We're going to go over it in class tomorrow. I would highly encourage you to try it on your own though. Figure out what your intuition is and then we can change your intuition to get better.
I don't know where your case is.
Oh, good. Sir, how are you?
We need a final one.
Go away, go away, go away.
Mr. Mack, your stapler's on my desk.
My stapler what?
Never mind.